Hi everybody, welcome to Recitation covering modules 1 and 2, so types and names and choice and iteration. So just a overview, welcome to the first recitation. We'll be having these every week except for exam weeks, just because we combine the exam review with the preceding modules review. And then this is just a fun little graph of like at least in my opinion, like the coolness or how interesting each module is, compared to its relative difficulty. So towards the beginning, stuff's getting cooler, but not nearly as cool as what we'll get to further on in the course. And so first, we'll just cover types and names, and then we'll get into choice and iteration. I guess first we have a little introduction as to what each week will look like for though first. Uh, so on Mondays, there'll generally be the lecture for Module N. And then Tuesday, the recitation for that module will be posted. And then on Wednesdays, we expect you to have completed the previous module's assignment. You don't have to turn it in, but we strongly recommend that you complete it in order to learn the content. And then also on Wednesdays, you'll be in completing Studio N during your lab section. And on Fridays, Professor Shook will post the studio review for Module N. And of course, TA office hours will be 6:30 to 9:30 Mondays and Wednesdays, and 7 to 10 p.m. on Tuesdays. And TA office hours will always be in Herb Hour 222. They start this Monday. So I guess yesterday, whenever you're watching this.
Okay, so to start off with Module 1, um, the main thing that was introduced was types and names. So, what is a variable? A variable is a container that holds a certain piece of information called a value. Um, so this can be set to whatever value you want it to be set to. So, for example, it can store temperature, and that would be like a number, or a user's name, so it'd be a string, and then whether you've had toasted raviolis, which would be like Boolean. And then in Java, a variable holds a certain type of information. This is called a data type. So, like I mentioned above, with the three variables, temperature with a decimal would be a double to hold that number. The user's name would be a string, and then whether you've had toasted raviolis would be a Boolean. So how do you create a variable in Java? There's two main ways to do this. The first one is to tell Java the variable exists without giving it a value. This is declaring a variable. So here we have two examples. Boolean is cool and int age. And then the second way is giving the variable a value, so initializing it. And um, this is, for example, double current temp equals 75.53, and this is giving it initial value so that it can be used. And then in the second example with age equals 20, if you have already declared age, like in the example above with int age, then you're free to just assign it a value without saying int age again.
Cool. So just a quick recap, declaring, you're basically just telling Java, hey, heads up, this variable's gonna exist. And then you just tell it the type of variable you have, and then the name you'll be calling the variable by. And I guess just like a quick heads up, you can't start your variable name with a number, because Java will think you're typing a number, and like won't be able to recognize it as a variable name. For the most part, you can name your variables pretty much whatever you want, though. Just make sure you don't use like a keyword in your variable name, but you have pretty much free reign. And then initializing, you're just telling Java, hey, go ahead and hold this value in this variable. So you have the name, whatever you named your variable previously, and then you're setting it to the value. And of course, for this line, you must have already declared the variable name, like I did in the declaring section, because Java needs to know at some point what type it should be. And if you want to both declare and initialize at the same time, you just do the data type, then the name, then the equal sign, and then value. Cool. So here's a bit of a silly example, but I like to think of variables as just little containers that can hold like a value. So let's say I have this line int my age. Then I create a little container, and we know its name is my age, but it doesn't have anything in it, so it's just empty. Then in line two, I both initialize and declare the variable Steve age, and I give that variable the number 33. So 33 is stored in the container for Steve's age. And then line three, I have the my age variable, um, which I which I already made earlier, but I set it equal to 20. So now that same box from earlier has the value 20 in it, and now I can say add value to it or like use it in in a expression. But before I couldn't do that since there was nothing in the container for my age. And and as we know, once you've like put a value in a variable, the value of like your variables can depend on other variables as long as like there's a value in the variable that you're trying to use. So, for example, after I set my age to 20, I could do Steve age equals my age plus 7, and that would set Steve's age to 27. Or I could do my age equals my age minus 3. Somehow I got 3 years younger, and then I'd be 7, and then the variable would be 17.
So to elaborate on how this assignment works, everything on the right side of the equals is evaluated. So if that's an expression or an equation, that will be evaluated first, and then that value is taken and stored um, to that variable on the left. So this is what makes it so that you're able to say my age equals my age minus 3 because the right side is evaluated first and then assigned to the left side. Um, and then kind of diving more deeply into what the data types are. So the primitive data types that we'll be working with are ints, doubles, booleans, and chars. And we'll be mostly working with ints, doubles, and booleans, especially in this module. Um, and so that what that means is that it's kind of a small unit of data stored directly by your computer, and it's like the most basic type, essentially. And then the other data types that we'll be working with are objects. So you've already seen string and scanner, and we'll be introducing random pretty soon as well. And so these just have some more complicated data that's being stored, and so they're not as simple as just like an int, double, boolean, char. And we'll expand more on this in Module 7, so that's something to look forward to. And then when do you include data types? So one thing we've already seen is when you're declaring a new variable, you say like int dozen equals 12. And that's just giving a heads up basically and making sure you know what the data type is for that variable, and that's the data type that variable will have for the rest of its like lifetime. Um, and then when you don't want to include the data type is when the variable has already been declared, um, because Java is a strongly typed language, meaning it holds on to that type for that variable. Um, it already knows what that type is, and you do not need to redefine that.
Cool. So just a little exercise for you to think through. We'll give you like a second to pause and think through these on your own. But let's say we gave you these following variables names, but what ty data types might you use for the following variables? So go ahead and pause, and we'll and like do this on your own. And then we'll tell you what the answer is in three, two, one. So hopefully you thought about all these at least a little bit. So student GPA, we definitely would want to use a double for that data type since you always have your decimal included in the GPA. But school name, that's just a string of characters, right? And so we'd want to use that as a string since it's a collection of characters. Then is tall, it's kind of telling you whether or not someone is tall. So I would definitely use a Boolean for that. And then ant population, you can't have half a ant, so I would use an integer for ant population or like anything related to population, stuff like that. Song length, I could see a couple answers for. Like, let's say you wanted to represent it as like the minutes and then like colon and then the seconds, then you might use a string for that. Or if you wanted to put it in like terms of number of seconds, then you could use an int. Or yeah, I feel like those are probably the best options. I mean, you could technically do a double, but it would be tricky since like time is stored in base 60. Um, but anyway, then candy cost. Well, candy isn't going to cost just a whole number. It's probably going to have some cents attached to it. And so I'd represent that as a double. And then lastly, games won. You can't really win half a game. So I would definitely represent that as an int. Cool. And then more fun, probably more fun stuff. How can we actually print in Java? So there's two main options for this. You can type system.out.println, and make sure you don't put a like period between print and ln. It's all one thing. And then in parentheses, you put whatever you want to print. So in this case, hello world. When you use these quotation marks, it's just like you're just directly typing out a string. Alternatively, we could do system.out.print, no ln, and then parentheses, whatever we want to print out is inside the parentheses. The difference between these two options is if you use println, you'll display your message on a brand new line. It's like hitting enter and then type and then printing your message. But print just uses the previous line and just prints whatever you set to print on the same line you were using previously. So I'd say most of the time I'm definitely using println. But if it works better for your situation, go ahead and use print. But how can I go ahead and print numbers in Java? So there's a few options. You could put the number if you know like it's going to be the same number every time. You could also just include the number inside of the quotation marks, like in the first example. Or in the second example, let's say you might like change the number later on. Then you can do hello world with a usually with a space because you'd want a little space between where you print the like previous word and the number following. And then you could just do it looks like a plus sign, but in this context, it's concatenation or adding multiple strings together. So basically, when you type this, your Java will look, see, oh, this is a string, and you're using the plus sign. That means you're concatenating. This is a string. So basically, it'll convert one to a string and then add it onto the hello world string. And then on the third line, Java follows like parentheses. So it'll look at what's inside the innermost parentheses first, which is 3 minus 2. So it'll solve 3 minus 2, and that evaluates to 1. And then it'll use concatenation to add 1 to the previous string. So they'll all print hello world space the number 1. And then yeah, just note whenever you concatenate a number in a string, the number's converted to a string first.
Okay. So a couple more do's and don'ts for printing variables in Java. Um, so um, printing a variable like the double amount, which has already been initialized here, we still do this like concatenation, and it's kind of the same concept as what Dorian just talked about with printing numbers. Um, and you want to make sure that you use that concatenation and enclose each part in quotations. Otherwise, it's going to read your variable name as a literal string and just print out your variable name. So in the second example, Jim owes me amount dollars. That's just all going to be printed literally, Jim owes me amount dollars. So, in other words, you must use concatenation to print variable values with other strings. Um, so just remember that anything inside quotation marks will be treated as a string. Um, and then without the quotation marks, it'll treat it as a variable name. And then lastly, how can I get input from the user? By using a scanner, which we've seen in our first studio. So here's a code example that all you can pause and think through on your own. Um, but just kind of think about what each line is doing and what you expect the behavior from this chunk of code to be. So I'll give a second. And then now I'm going to go on to the answers. So here we are. Um, so with this first line, scanner in equals new scanner system dot in, this initializes the scanner. So this allows you to, this kind of sets it up so that you can use it in the next few lines. Um, Next, we have string name equals in.next, and in.next gets a string from the user. So this is what you should use if you need just one string. Um, then next, in.nextInt gets the next int. I think that one's fairly self-explanatory, and same with in.nextDouble. So these ones just take in the next int or double. And then next, same idea, in.nextBoolean takes in the next Boolean. And then lastly, in.nextLine gets a multi-word string from the user. So the entire line that the user inputs until enter or like the new line character will be included in this in.nextLine. All right.
Cool. And then just getting into some basic math operations in Java. We have addition, subtraction, did I say addition?
Yeah.
Wait, I'm just gonna get start over.
Okay.
Um, all right, so now let's get into some basic math in Java. So we have addition, subtraction, division, and multiplication, which I think use pretty standard like symbols for each of these operations. Um, and then for the most part, addition, subtraction, and multiplication work exactly as you'd expect. There are some exceptions to this, though, when working with extremely small or large numbers. And so, if you're interested in that, take CSE 1302, so Intro to Computer Engineering, to learn a little bit more. But division is where stuff gets a little more complicated. For one, I mean, pretty familiar to like regular math. You can't divide by zero. And if your code attempts to do this, your computer will do what's called raising an exception. And it'll basically just stop your running your code. You've done something that's impossible. And so your code won't work. But then, otherwise, if you're dividing two ints, Java will truncate or ignore whatever decimal that would have happened if like you were normally dividing something. So, let's say I'm dividing 5 by 2. Well, in like math, we'd think of that as 2.5, but Java, it reads both of those as int, so it does integer division, and you only have 2. Similar for 3 divided by 7. Those are both integers, and so since like the answer would be a decimal, Java just ignores the decimal, so it's only 0. And then finally, 10 divided by -2. That one's as expected, it's just -5. But if we want, let's say we want to have the decimal in our answer, then either the numerator or the denominator must be a double. So let's say we do 5.0 divided by 2. Well, the point 0 tells Java, hey, this is a double. And so it'll do double division and we'll get 2.5. Alternatively, we could, if we do 3 point divided by 7.0, that would be also be doing double division, but even though it's the denominator that is the double this time, just one of them has to be doubles, so the answer will be 0.428. And then lastly, both 10.0 divided by 2.0 or -2.0, those are both doubles, so it'll give us -5.0. And I guess one trick, if you want the number to be a double, you technically can just do 5 point. You don't have to type the zero. I kind of like to type the zero just so it's a little extra clear though. And then here are some examples for you to try on your own. Um, I'll give you a few seconds to go ahead and see what would Java do for each of these math problems. All right, so now we'll go over the answers for all these problems. So the first three are pretty straightforward. It'll just do regular division or regular addition and then regular multiplication. So A will be 12, B will be positive 13. It doesn't matter. Like you just put the negative sign in front of the number to make it negative. Nothing special with that. And then C will be 55. D is where it gets a bit interesting. So basically 5 times 2.6 would be a double, right? But Java won't automatically convert this double into an int. So this line actually wouldn't compile because this result would be a double and we are trying to store it in an int. We'll talk about typecasting a bit more in a second though, so we could use typecasting to make this compile. And then for this next one, E, 5 divided by base, it's what we just talked about with integer division. So 5 divided by 3 is 1 point, I believe 6 repeating. Um, and so it would just, Java would just cut off that 0.6 repeating, and so the answer would just be 1. Very similar. 11 divided by 3, that would have a decimal. And so Java would cut off the decimal, and it would just be equal to 3. Uh, and then, kind of similar to int d, but int g. Basically, we're trying to do double division here. And so the result of 12.5 divided by 3.3 would obviously be a double, but we'd be trying to store that into an integer. So again, this line would not compile. You'd have to like typecast this in order to make it actually run. But int h, 8, negative 81 divided by 4, that is chill. It'd just cut off the decimal. Yeah. All right, and then here's where we get into some more interesting stuff. So, double I, 5 times 2.6, that'll actually be double multiplication, um, since we are multiplying an int by a double. So that'll give us the actual result. I don't feel like doing that off the top of my head, but the normal result of 5 times 2.6 will be stored in double I. However, with double J, we're dividing 5 by 3, but they're both ints. So it will do integer division. So it'll still be 1, but then since we're storing it in a double, it'll still have to have the decimal. So it'll be 1.0, which is a little weird, but since it's doing the integer division first, then it'll convert it to a double. Very similar for K. It'll do 11 divided by 3, but that's integer division since we didn't put like a point 0. And so it would be just be it would be 3.0 for that result. But here we have double L. It's a double divided by a double. And so it would do double division. It'd be the result. It would equal the result of that. I don't feel like doing that off the top of my head, but it would be the actual, like in math, answer 12.5 divided by 3.3. All right, and then double M, last but not least. It's still integer division. It doesn't matter that we have this negative sign here. And so negative 81 divided by 4, that'll give us negative 20. And since it's a double, it'll just put a point 0 at the end. Wow.
Okay, so now to talk about typecasting. So, what if you had a situation like on the last slide where you have integers, but you want to divide them like they're doubles and get that double answer with the decimal point? So, typecasting allows you to convert a variable to another data type for an expression, and this does not affect the original variable. Quick note before I go to the example, you can't typecast primitive data types like ints into strings. So you can't just try to go string and then whatever your int variable is. That's not the way to do it. But here is the example: int x equals 7, int y equals 2. And then if you wanted to get the double, like more accurate um, division answer from these two ints, what you would do is you could typecast x to be a double. So making sure that you have the parentheses there to do it before the division happens. But this would typecast int x to be a double. So you would effectively have 7.0 divided by 2, which would give you the correct double answer for z. So now we're going to cover Boolean expressions. So this is like making comparisons between different variables and values. So to start off, we have our greater than and less than operators. These are pretty standard. This is like what you've seen in elementary school math. Next we have same as, so it's the double equals. And the distinction between the single equals and the double equals is that the single equals is used when you're assigning something a value or assigning a variable a value. And the double equals is used when you're checking if two things are the same value. So that's a pretty important thing to make sure that you're doing correctly in your code. Next, we have not equal, which is exclamation mark and then equal sign. And then we have greater than or equal to and less than or equal to. And so for our example here, let's say int x equals 5,000. So the expression 7 is greater than x would be false. And then um, the truth value, I guess, of the expression -4 is greater than or equal to -22 is true. Um, 5,000 equals x is true. And then 10 not equals 10 is false.
And then, very related to Booleans, we want to have an ability to make a choice in our code. So do one thing depending on a certain condition. And so let's say we have a good old scanner, and then we print to ask the user, how old are you? Well, they give us their age as an integer, of course, and then we check if age is less than 18. And if this condition right here is true, then we'll go ahead and print out you're very young. And note that we have these curly brackets right here. So basically, if this if statement is true, it'll do everything inside these curly brackets. Otherwise, it'll skip to the end of the curly brackets and only do what's after the curly brackets. So your code will only print you're very young if the user entered an int less than 18, but the variable age increases no matter what, since it's after the curly bracket. But what if we want to do something when a condition is true and something else otherwise? Well, then we can use an if-else statement. So we have int age equals next int, just like before, and then we check whether age is less than 18. And then in that case, we print you're very young. But this time, right after the curly bracket, we have an else, and then an open bracket, and in here we have system.out.println, you're ancient, and then an end bracket. So basically, does what this does is, if the integer is less than 18, it'll print that you're very young. But if the age is over 18, then it'll print you're ancient. And just pay very close attention to where these curly brackets are, because the if statement, I always say like it controls everything within its curly brackets, and the else statement controls everything within its curly brackets. And the else always needs to come directly after the end of the if statement.
Okay. So another way to add another layer of complexity to the if else statement is with else ifs. So this can add a second, third, etc. Condition to this if statement, and you can test multiple conditions. So, for example, adding to our age example, um, this will first test if the age is less than 18. And if it is, it'll still print that same you're very young statement. If it isn't, though, it'll go on to the next um, condition, else if age is less than 30. So if that one is true, then it will print out you are aging. If that one is also not true, it'll continue down to the else statement and it will execute the else statement, so saying you're ancient. So essentially, what this will do is if the first two conditions are false, meaning the age is greater or equal to 30, then that else will execute, but otherwise, it'll get stopped at one of those two checks and execute that code. And we're missing a curly bracket here, but that's okay.
Oh,
So watch out for that in your code, but that's fine for the slide. Okay, so um, for like some examples of what would happen, if let's say the input was 17 for age, the output would be you're very young because that would get stopped right at the first if condition and would print out that you are very young. Let's say the input was 21 though. It would pass the first condition, it wouldn't print that statement out, and then it would go to the next condition, else if age is less than 30. Since that's true, then it would print you are aging. For the third input with 35, it'll first check if 35 is less than 18, which it's not. So it skips that print statement. Then it goes on to the else if age is less than 30. 35 is also not less than 30. So it skips that print statement. And it goes to the else, which is like the catch-all for everything else. And it will print you're ancient.
All right, and then here's just like a quick diagram, one way to visualize the if statement. So here we have is heads, which is a Boolean, kind of representing, say we flip a coin, is it heads or not? So heads is true, false is tails. And then we check if is heads and true, and so if it is true, go ahead and print go to a game. But if heads is false, if is heads is false, we go to the else statement and we print watch a movie. And then, no matter what, we will go on to the next statement in our code. So whatever is after the end bracket for this else statement will definitely be run. And then, just a pro tip, if you want to look like a pro programmer, I mean, not required, but it definitely makes you look like a better programmer. It's good to avoid if statements that look like this. So if we're checking if condition equals true, and then do whatever is in the if statement. So, for example, let's say I wrote that one example of this is like if I wrote if the condition x is greater than y is true, then I'd print x greater than y. Well, this actually just really creates a redundancy since x is greater than y, or any condition you would type here, will already evaluate to either true or false. So, for example, let's say x greater than y is true. Then we just be printing if true equals true, which is redundant. So you can just write x greater than y and know that it'll end up resulting in a Boolean whenever your code is actually run. Um, and so you don't need to like check if it's equal to true. Um, and then if you want to check, only run something when the condition isn't true, use the exclamation point in front of the condition. So if you don't want to like change the this to like a less than or equal to sign, you could just put the not in front of the condition. But yeah, either way is fine. I'd probably just change the greater than sign to a less than or equal to sign, but it's honestly personal preference. Just don't write equals equals false. It's just bad style, in terms of your code.
Okay, moving on to iteration. So this is when we need to repeat a task several times. Instead of repeating the exact same couple lines of code multiple times, the better way to do this is to use for loops and while loops. So for loops is if you want to repeat this task a definite number of times, and if you know how many times that is, basically. Um, and then while loops are if you want to repeat the task until a condition is met, so you don't know when that condition will be met or how long that will take. So kind of breaking down what a for loop looks like, um, we start with the variable declaration. So you say for int, you can say whatever that variable you want here. Int I equals 0, you could say for int x equals 0, you could say for int count equals 0 if you want to be more descriptive with what you're counting. Um, Next is the condition, also known as a predicate, which is under which conditions will this continue to happen, basically. So in this example, starting the integer I at 0, this will execute until I is no longer less than 10. So once I becomes 10, this will not happen anymore. And then the third part is incrementing or um anyways,
Real.
incrementing or how do you say
I think decrement is how I
it?
usually say it.
Okay, this is
It's
not
a
a word I
weird
say
word
very
though.
often in my day-to-day.
Very true, yeah.
Okay, I'm just gonna start from the third part.
Hmm.
Okay. The third part of the for loop is incrementing or decrementing the variable. So this will control um, how you are increasing or decreasing I to get that number of times that you want. Um, so in this example, I plus plus will just increase it by one each time. But if you wanted to, you could do I minus minus and take one away each time. Or you could do I plus equals two and add two each time. It's up to you and the needs that you have for that specific body of code. And then, of course, inside will be the body. That will be what actually happens in each loop. Okay, so this kind of shows, I guess, conceptually how you'd move through this on each loop. So you start at the beginning where this one is, and that's where you initialize your variable. After the variable initialization, it goes on to checking the condition. And so if that's true, following the red line, then it executes the body at this step 3. So it executes the code. Then it moves on to increment the variable I at 4, and then goes back, checks again if the condition is still met, and if that's true, it does that loop again. So that's kind of the red loop. And then at that checking condition stage, if it ends up being false, so let's say in this case, I has reached 10, I is equal to 10, then we go on to this blue line, right? This condition is now false, and we end the for loop.
Cool. And then moving on to the other type of loop, a while loop. Basically, we just write it while, and then in parentheses, we have a condition. And then in curly brackets, we just have whatever we want our while loop to do while it's repeating. So here's a bit of a silly example of a while loop. So while, um, I believe math.random's in like the textbook. I'm not sure if Professor Shook went over it in lecture. But basically, it gives you a random number between 0 and like zero point 0.9 repeating. Like it won't include 10, but it'll include every number up, every like decimal up, or not 10. It won't include 1, but it'll include every decimal up to 1. And so, while math.random happens to generate a number larger than zero point 0.5, we'll go ahead and print, nope, not this time. You don't get to end the loop. Uh, and then once math.random finally chooses a number that is less than zero point 0.5, the loop will end and you'll continue executing the code after the end curly bracket. So, just a quick example. We'll show you the answer after you have some time to think about it, but at least take a couple minutes to like write it out on your own, and at least try to think through this. So, what code would you write if you wanted to flip 10 coins? And again, just use math.random. Um, and then like let's say that it's heads when math.random happens to generate something that's over zero point 0.5. And then we wanted to count the number of heads that we flipped whenever we flipped the 10 coins. So that's the first question. It'll be on the left for that code. And then what code would you write if you wanted to flip any number of coins until you got 7 tails? So all you care about is getting up to 7 tails. So take a couple minutes, try those out, and we'll go to the answer in 3, 2, 1. All right, here's the answers. So for the first one, the code is on the left. So we start the number of heads out as 0, and then I'd say you should probably make this at the beginning of the loop because let's say after the loop you wanted to print the number of heads that happened whenever you flipped the 10 coins. Well, if we made this variable inside of the for loop, we wouldn't be able to access it outside of the for loop. So, just a quick tip. And then we have our for loop. So for int x, and again, you can name this however you want. Maybe coin flips would be more descriptive, but start x at 0, and then we continue as long as x is less than 10, and then we increase x by 1 each time. And then within the for loop, we check whether math.random is greater than 0.5. So if it's greater than the 0.5, we decided that it's heads. And so we put num heads equals num heads plus 1, which is the same thing as writing num heads plus plus. Just felt like writing it that way in that spot. And then this code will repeat until x is equal to 10, which would have been 10 iterations. And then we go down to the code, whatever happens after. Cool. And then you'd probably want to add a print statement after this code if you wanted to like test whether it works, just to print the number of heads that got printed out. And then for the second problem, what if we wanted to flip any number of coins until we got to seven tails? So similarly, we want to make this integer like set number of tails outside of the while loop so that it can be used in this condition. So num tail starts out at 0, and we continue with this while loop until num tails is equal to 7. So in this if statement, we check math.random and see if it is less than zero point 0.5 because we're trying to count tails. And if it is less than zero point 0.5, we'll add 1 to the number of tails. And then we continue repeating until eventually the number of tails equals 7. And then we go out of the while loop and maybe we could say like we got 7 tails. And then I guess one other thing you could try on your own is adding like a variable to keep track of how many coins you flipped until you got 7 tails. Mhm. So here's some just like silly exercises. No, don't have like super in-depth instructions, but if you want to just try out all these concepts a bit more on your own, go ahead and like try writing these out and test them by running them in VS Code. So, what should we use to print numbers 1 through 10? Should be fairly straightforward. And then next, you could try to print whether or not the number the user enters is even or odd. And then you can also try using this both with and without if statements. Because you could use just regular Boolean like make a Boolean variable to represent this. Or you could like print it using if statements. Try both ways. And then next, you could try printing random numbers that you generate between 1 and 15 until a number greater than 10 is generated. Another one, can all go ahead and check if like you choose a string to use for a password, and then you check whether and then you get some input from the user and check whether the password the user inputted is correct. And then to make the code a little more complicated, you could like keep asking the user until eventually they enter the correct password. So just repeatedly ask them till what they input matches whatever string you choose for the password. And then last but not least, you could try simulating rolling like a 20-sided die again with like some random just by generating random numbers until you get a 20. So, try all these out on your own. If you have questions, feel free to ask like in the comments or always feel free to go to office hours.
Okay, so just some upcoming things in 1301. Um, so this Monday or potentially yesterday, office hours start for TAs. So like we mentioned in the beginning, this is 6:30 to 9:30 on Monday and Wednesday, and then 7 to 10 on Tuesdays. And those will be in Urbauer 222. And then Wednesday during studio, you'll be working on Gambler's Ruin, which is a pretty fun studio. As a reminder, though, please disable Copilot and inline suggestions. This went out in a Canvas announcement, and your TAs will be able to help you as well. Um, it's just, since this is an introductory course, Copilot will be able to basically give away basically the entire answer for a lot of these things in the course, which is just not going to set you up well for um, learning in general and also for the exams in this course. So that is something that we need you to disable. And then assignment one is expected on Wednesday. Again, you don't need to turn this in or demo it to your TA, but you should do it and it should be done around this point. And then next week, you'll be learning Module 3. So you'll be doing the Module 3 lecture and studio, and then you'll be quizzed on Module 2. And so these three modules, 1, 2, and 3, will be the contents of Exam 1. So yeah, start getting ready for that. We'll be doing a review for the next recitation.
Mhm.
Cool.
Thank you for
Thank
watching.
you.
Bye bye.